Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering a question from one of my end-of-topic worksheets from chapter 5 of P1, straight line graphs. This is question number 11 from my worksheet, and question number 10 from the Solomon K C1 collection, from the P1 Edexcel collection of Solomon papers. And this question here is about a straight line L, which has a gradient of 3 and passes through the point -6, 4, point A. And the first part of the question tells us to find an equation for the line in the form y equals mx plus c. Now, for us to find the equation of a straight line, we need two pieces of information. The first of which is the gradient of the line, or one of which is the gradient of the line, which is 3, as the question tells us. And the second piece of information we need is a point on the line, which again we have been given explicitly, -6, 4. Alright, so we've got to find the equation of the line L in the form y equals mx plus c. You can use two different methods. The one I prefer, y minus y1 equals m times x minus x1, where y1 and x1 are the y and x coordinates of the point given, that you know that's on the line, and m is the gradient. So you have y minus 4 equals 3 times x minus -6, which is plus 6. And then we can just expand the bracket. So we have y minus 4 equals 3x plus 18. We can add 4 to both sides, so y is equal to 3x plus 18 plus 4 is 22. And there we have the equation of line 1. So this is the equation of line 1. Okay, so we've answered the question. Now there's another method we could also use, which uses the method of just taking the equation of the line y equals mx plus c in that form, and just say, okay, we know that y equals mx plus c, where y and x would be the y and x coordinates of that point on the line. So you can say 4 equals, and m is the gradient, 3 times -6 plus c, and this way we can find what the y-intercept is. So you have 4 equals -18 plus c, add 18 to both sides, c is equal to 22, so we can just put everything in the right place. Y equals m, the gradient x times x, 3 times x plus 22. Same answer, okay, slightly different method of getting there. So that's part A. Now for part B, they told us that the straight line M has the equation x minus 7y plus 14 equals 0. And we're told that M crosses the y-axis at the point B and intersects the line L at the point C. And we need to find the coordinates of B and C. So we got to know what the equation of the line L is, which we just found, which is y equals 3x plus 22. Just make sure that's correct. Yes. So for finding the coordinates of point B, what we can do is you can find out where the point crosses the y-axis. Now we know on the y-axis, the x-coordinate is always 0. The y-axis, the x-coordinate is always 0. So we can take the equation of the line M, which is x minus 7y plus 14 equals 0, and we can replace the x with 0, in which case you're going to get -7y plus 14 equals 0. So you can say 14 is equal to 7y, and then 14 over 7 is equal to y. So we know that the y coordinate of this point B is equal to 2, and we know that it passes through the point x equals 0, which is on the y-axis. So the coordinates of the point B are 0, 2. So that's how you can find where it crosses the y-axis, and we found the point B. Now then it tells us that the line that they gave us, which is line M, and the line L, which we just found the equation for in part A, they intersect at the point C. Now to find the coordinates of the points where two lines intersect, we have to solve the equation of those two lines simultaneously. So we're going to take x minus 7y plus 14 equals 0, and we're going to take y equals 3x plus 22, and we're going to solve these two equations simultaneously. Now again, here there's two methods we could use. One is like using substitution, which this question I think is like kind of set up for, where you take what y equals from, or what x or y equals from one equation and substitute that into the other. As you already have y as the subject of this formula, we could replace the y in this equation with what y is equal to. So that's quite easy to do. So we have x minus 7 times, instead of y, I can put 3x plus 22 plus 14 equals 0. So you have x minus 21x plus minus times plus is minus. You have 140 plus 14 minus 154 plus 14 equals 0. So you have negative 20x, and you have minus, that's 140 equals 0. So if you rearrange that, you're going to get minus 140 is equal to 20x. Divide both sides by 20. You're going to get minus 140 over 20 equals x. That gives you negative 7. So x is equal to negative 7. And we need to find the y coordinate, which we can do by substituting that back into this equation here. It's already set up for y. So we can say when x equals 7, when x equals negative 7, we can say y is equal to 3 times negative 7 plus 22. So y is equal to negative 21 plus 22, which is equal to 1. So that means the coordinates of the point C, it was called C, wasn't it? Yeah, they intersect at point C, are negative 7 and 1. So we have now the coordinates of point B and the coordinates of point C, okay, found. Now, as I mentioned, there's another method we could use for solving this pair of simultaneous equations. That's by what's called elimination. So what we can do is we can set them up so that the x, y's, and the numbers are constants are on top of each other. So we have x minus 7y plus 14 equals 0. If I rearrange this equation, I can have 3x minus y plus 22 equals 0. That's one way I could rearrange it. Have the x, the y's, and the numbers all in line, and then I can modify one of the equations to make it look like the other. So if I multiply this first equation by 3, for example, the x coefficients will be the same. So I modify one of the equations to make one of the coefficients the same as in the other equation. All right, I could make the y's the same by multiplying this by 7. I can make the x's the same by multiplying this by 3. I decided to make the x's the same, so I have to multiply every term in this equation by 3. So I have 3x minus 21y, and 3 times 14 is going to be 30 plus 12, which is 42, equals 0. And I can subtract these two equations, thereby eliminating the x's. So I have minus y minus 21, which is minus y plus 21, which is 20y, and 22 minus 42, which is minus 22 minus 42, which is minus 20 equals 0. So I have 20y is equal to 20, so y is equal to 1. And if I substitute y equals 1 back into this equation here, I have y equals no, not into this equation here. I want to find what x is, so I can substitute. I think this is better to use this equation. So put y equals 1 to this equation. I have x minus 7 times 1 plus 14 equals 0. So that gives you x plus 7 equals 0, in which case x equals negative 7. So I get the same coordinate, minus 7, 1, for the point C. So that's the answer to question part B of this. And now I'm going to go to part C. And it says, show that angle BAC equals 90 degrees. So let's get some of the information we need. Okay, so we know that the 3 points A, B, and C, negative 6, 4, 0, 2, and negative 7, 1, show that angle BAC is 90 degrees. Okay, so to show that the angle BAC is 90 degrees, we have to show that basically, if we think about it, let's just draw a little sketch just to picture what's happening. We have our axes. Let's make that straight. Okay, so we have our the point A is negative 6, 4, the point B is 0, 2, let's say that's point B, 0, 2, and the point A is negative 6 and 4, somewhere up here, and the point C is negative 7 and 1, somewhere over here. So we've got to show that BAC is 90 degrees. Negative 7, so we're going to be over here actually, and 1. Okay, that's C, negative 7, 1. And A was negative 6, 4. So we've got the line from there to there. We've got to show that this angle is 90 degrees. Okay, if this angle, so we say if the angle BAC, oops, what am I doing? If the angle BAC AC is 90 degrees, then we can say that the line BA is perpendicular to the line AC. The line BA and the line AC will be perpendicular. Okay, so how can we prove that they're perpendicular? We can think about their gradients. So we can find the gradient of the line AC and the gradient of the line AB. Okay, so let's find the gradient of the line AB. The gradient of the line AB is going to be the change in y over the change in x between A and B. So I can say it's going to be 4 minus 2 over negative 6 minus 0. Okay, which is going to give you 2 over negative 6, which is going to be negative a third. And the gradient of the line between A and C, AC is going to be the gradient between these 2 points, which is going to be 4 minus 1 over minus 6 minus 7, which is 3 over minus 6 plus 7, which is 1, which gives you 3. So we can see that these two gradients are perpendicular. So we can say as the gradient of AC, or we find the gradient of AC times the gradient of AB is equal to 3 times minus 1/3, which is equal to negative 1. So therefore we can say, therefore as the gradient of the line AC and the gradient of the line AB, okay, as the product is equal to negative 1, therefore they must be perpendicular. So that's enough for you to give the reason. You have to state a reason. You can't just leave it at that. Okay, they're negative reciprocals, therefore they're perpendicular. No, you have to state. Show that when you multiply them, they get negative 1, and then state as the product of their gradients is negative 1, they are perpendicular. Or you can state in words that as the gradient of AB is a negative reciprocal of the gradient of AC, therefore they are perpendicular. Something like that. There must be some qualifying statement. You can't just leave it, at this step here. You will definitely lose a mark. You must make a statement to show that the fact that they're negative reciprocals, or to show the product of the gradients is equal to negative 1, that they are perpendicular. Very, very important for you to show that. Okay, then it says find the area of triangle ABC. Now, to find the area of triangle ABC, we have got, let me just think about the diagram. We've just drawn a diagram like this. Okay, and to find this area, we know that this is now a right angle triangle. So that's going to help us. So if we take, this is ABC there, so that's A, and that's B, and that's C, or is it the other way around? Yeah, that's the way. We know that that's a right angle triangle. So if I find the length of AB, and if I find the length of AC, then I can take one of them as the base and the other one as a vertical height. Half times base times height. So the base and height must always be perpendicular to each other. So I can take one of them as a base, the other one as a height, and I'm done. So we know that the coordinates of A are minus 6, 4. Let me just, okay, so A is the length of the line between A and B. So let me write here, minus 6, 4. This was 0, 2, and this was minus 7 and 1. Okay, so I know that the length between A and B is found by the square root of, it's like using Pythagoras basically, the square root of the difference between the x coordinates, which is minus 6 minus 0 squared, plus the difference between the y coordinates, which is 4 minus 2 squared. Okay, which is going to give us the square root of, that's going to be 6 squared, which is 36, and that's going to be 2 squared, which is 4, so it's the square root of 40. And the length of AC is the length between these two. So you've got the change in between these two, sorry. You have minus 6 minus minus 7, which is minus 6 plus 7 squared, plus the change in the y, which is 4 minus 1 squared. That's going to give me the square root of 1. 1 squared is 1. And that's going to give me 3, which is 9. Square root of 9. So that's going to give me the square root of 10. So basically what we have here is that the area is equal to, so the square root of 40, if you write that in simplified third form, that's like 4 times 10. That's going to be like 2 times root 10. It's a root 4 times root 10. So that the area of the triangle is a half times the base. Let's take that as 2 root 10 times the height, which is root 10, which these cancel out. So you're left with root 10 times root 10, which is 10. And you have root 10 squared, basically, which is 10 square units. So there we have the answer to part D of this question, and that concludes this question, question number 11 from the end of topic worksheet of straight line graphs from P1, and question number 11, this is question number 10 from the Solomon K collection of papers. So if you would like to see other papers or other questions from the Solomon K collection, you'll find the playlist over here. Other questions from this end of topic worksheet you can find in the playlist that should appear in this area here, and you'll find questions from straight line graphs in general from P1 in this playlist. You can subscribe to my channel by clicking the link that appears in the section. Thank you for watching, and see you soon.